Sure.
I think what you're doing is extremely interesting.
But I want to know the extent to which you are looking at heritability, because it's very clear that schizophrenia in particular
Yep.
is not just like one guy, it's
Yep.
very much in a family history.
Yeah, so, all mental disorders really, are characterized by being partly genetic, at least. In very severe cases, they might be purely genetic. The problem in the case of schizophrenia specifically is that over 1,000 different genes have been implicated as potential causes for the disorder. And we know that there isn't any one particular gene that causes the disease, right? So in our work, what we do with the stem cells, rather than try and genetically engineer a stem cell to be lacking one gene or to be carrying a mutation of one gene, we basically go to the source, we go to patients and we collect their stem cells directly. And when we do that, we're capturing the entire molecular genetic architecture of the disease itself in its intrinsic state. And from there, the next step is working out, are there common differences across all schizophrenia cases? We assume that every schizophrenia case is going to be genetically unique to some degree, probably harboring a different combination of genetic risk factors. But only once we have a good idea of common differences that we can start to work backwards and start to parse out individual genetic differences. And it also might be the case that given the complexity of the disease, that we will never have treatments that are purely individualized. And it might be that these, consortium of genes converge upon common pathways, and the pathway is really the pharmacological answer. That's our next generation of treatments, potentially, maybe. So the answer is, we're not doing that specifically at this stage. We're working at a lower level and going to work backwards eventually. Luckily for me, I'm pretty young and I have a lot of time on my hands, so I think I have time to maybe do that a little bit, but we'll see.
I'm pretty old and I don't, but I worked in psych for a long time.
Sure, yeah.
And I just wonder, are you also doing this kind of research on family members?
So at the moment, we are not specifically taking stem cells from a family trio or a family unit, say an affected sibling, an unaffected sibling, and then the parents. Right, yeah. But that is one approach that other people are doing. It's just not what we're doing at the moment. There's no right or wrong way, just different ways. Yeah.
I think what you're doing is extraordinarily interesting, and good luck.
Thank you, I appreciate that, yeah.
Yeah, is psychotherapy felt to be I'm sorry. Is psychotherapy believed to be important in the treatment of schizophrenia? Or?
For treatment, psychotherapy in general? Yeah, so I actually have a background in psych, that's where I started out, and this is actually one of my favorite facts about schizophrenia. The drugs don't work very effectively universally, right? 40% of patients will respond to those antipsychotics. However, if we start to really look at the statistical effect of various types of drugs and treatments in schizophrenia, things like cognitive behavioral therapy have a larger effect size. This means that on a generalized kind of level, therapy is actually fundamental to treating the disease. It's not preventative, but it is perhaps more therapeutic, maybe, than the drugs themselves. But I think for the therapy to be properly internalized, there probably has to be some kind of pharmacological stabilization of the patient, or we have to accept that not all cases are the same, and some might be more severe than others. But yeah, it's a very good question, and psychology is not lost in this. It's paramount. Yeah.
If you're
I'm sorry. Thank you very much.
all right. Now, if you're suggesting starting treatment before symptoms manifest themselves, how do you protect against treating someone that doesn't have schizophrenia?
Yeah, no, this is the problem, right? So there's been a long, this is something we've been talking about in the field for a long time. So if treating people when the disorder truly starts is too late, when do we start? And then are we going to be treating people who might never develop the disease? This is a long withstanding problem with early intervention. And it's a problem that we don't have an answer for yet. So part of it is, the trick here is probably likely to be that we have to do more work in identifying who is at ultra high risk versus just at risk. So there are people who spend all their time, their professional life trying to work out who is at genetic ultra high risk for schizophrenia. And this is an emerging thing. It takes time because you have to track people from very early in their lives, say in adolescence, through to adulthood, 10, 15, 20 years, to watch the developmental course of the disease to work out, okay, who really went on to develop schizophrenia versus who didn't, and what's different about them genetically. And then from there, it's like, we might be able to work backwards to work out who is best suited for early intervention. But with a disease like this, it might be something that takes a very long time if we ever get there, but that would be the goal.
Can you pass it on? Thank you.
So you've got your mini brain model. Have you considered testing a combination of the currently prescribed anti-schizophrenia drugs to see how that changes the development of those mini brains compared to a control?
Yeah, so basically, we have these established treatments, right? The question, was, if we have these little schizophrenia mini brains grown, intrinsically from schizophrenia patients, can we give them the drugs that they might be taking, or the drugs we use to treat the disorder, and see what actually happens to them? The answer is we could do it. There's no technical reason or ethical reason why we can't do it. It's not something we're currently doing, but we're working on the same problem. If there is something different about the schizophrenia mini brains, how can we treat them? Can we treat them? Can we reverse the problems that we see in them? I don't want to go into too much detail because I think it's beyond the scope of tonight's talk, but we are working on and have found ways to reverse at least some of the differences we see in them, such as like the difference in the number of neurons or brain cells that intrinsically arise. We have narrowed down on a number of molecules and pathways that might actually be involved in that. But we haven't gone so far as to give them the drugs that we use in the clinic. And I don't know if that would ever be a clinically appropriate way to actually intervene as well, because these drugs they're very intense drugs, and I think that they would probably have a larger effect on development than probably any genetic risk, short of very extreme and severe cases where a patient would be 100% likely to develop the disorder, and we're not even at a point where we could say that confidently. So, in principle, yes. Am I currently doing it at the moment? No, but we're working in a different way, so to speak. We're not focusing on existing treatments, but what are the next generation of treatments potentially, and what would be safe in the context of a developing brain? Yeah. Yeah, sure.
I'm not a specialist or anything, but the one thing that struck me early on in your presentation is the graph showing the incredible increase amongst Gen Xers of schizophrenia and other kinds of psychiatric diseases.
Yeah.
It seems obvious that there has to be some sort of environmental or alimentary cause to this. My wife has been saying for years that we're poisoning the environment and that's causing probably a lot of these things. I mean, it's some sort of speculation. We're not scientists. Yeah. But it's pretty obvious when you look at that thing.
Yep.
People our age, as all of us would say, we don't know all kinds of schizophrenics our age. But it's suddenly, and not just schizophrenic, but all these other mental problems of various sorts. So what do you have to say about those other factors?
Yeah, sure. So the question was, naturally mental illnesses affect young people, and this is true for schizophrenia, it's true for anxiety, depression, basically every mental disorder and class of disorder. And naturally then there must be some environmental influences and effects here at play. It can't just be biology itself, it can't just be genetics alone. And the answer is that's 100% correct. In the vast majority of cases, purely genetic cases of mental illness are more the exception than the norm. Almost all other cases are a combination of environmental inputs, in individuals carrying genetic risk, right? In the case of schizophrenia, it is a little bit more genetic than other disorders, but I do think that we are seeing increased rates of mental illness of pretty much all varieties in youth today than before. Now, you might say, oh, psychiatry's just improved. We've got better doctors now. We have more doctors. We're diagnosing more people. However, it's probably pretty likely too that, you know, with the advent of technology and, you know, connectivity, that's having a very strong effect too. I mean, we've never been so connected yet so far away from each other, and I think that this really boils down to the concept of stress. And stress has very profound impacts on the brain, especially the developing brain, and that's something that we can't escape. That's the biology that we can't escape, and we're exposing ourselves certainly to well, many different types of stress, but new forms of stress too that, you know, previously we hadn't as a civilization because of technology. So I think you're right in your suspicions there. Yeah.
You noted differences across different age groups. Are there other demographics that you studied, or any specific populations where the incidence was higher?
Okay, so there are, you know, naturally individuals, there are parts of the population that are at a higher risk of schizophrenia. There are, you know, purified cohorts that are at higher risk. People who have used drugs are at a higher risk just in general, and you can break that down further. People who have used, you know, stimulants and whatnot, but also ethnic groups, yeah, veterans. So again, you know, when it comes to that's a tough question. I don't want to say anything because I'm not an expert on the subject specifically. I think that largely comes back to the previous question. You know, again, these are people who have experienced substantial stress and trauma, and to think that that doesn't have a lasting effect on the brain is very naive. I did a PhD on stress. I really believe that, you know, people think that stress comes in and goes out, but there are long-term changes and the brain doesn't recover from all of them. And I think it's something that we've been talking about for a long time, and it could be that, you know, in veterans and other people exposed to a similar level of, you know, trauma and stress, that they too are at a heightened risk if carrying that, you know, genetic vulnerability as well. Yeah. All right, no other questions?
Is that it?
I think so, yeah. Perfect.
Awesome, great question.
Thank you, guys.